Let's do this question 21 together. It's good that you guys are these two questions done already. Let's just have a really quick review. A, we have a triangle. So for a triangle, we will have 3 vertex, 1, 2, and 3. Maybe let's color them in different colors. Let's use red as the first point, the first vertex, and then like the rainbow color, red, green, and then blue, and then this is the green, and this is like the blue. Okay, so now they say we need to reflect the triangle A in a line y equals to 2. So we identify this is like every point along this line will just have the same vertical coordinate as 2, right? That's why the whole line here will be the line for y equals to 2. Then we can see that this one is looking down. Imagine you have a pond, a lake that's really good, just like a mirror. So when you look into it, you can see that the red point here will reflect to be this point here. Why? Because there will be the same distance, the same vertical distance away from the line too. So you can see 1 step, 2 step, 3 step down. So they see also away from here 1, 2, 3. That's where we got this point. And then do the same thing. Then we can see this one should be the blue point, and this one should be the green point. That's how we got the shape B as the reflection of triangle A through the line y equals to 2. Good, right? And I think that we can also do the same thing for this one. Instead, this time we have in the line x equals to 1. So we can see that each line here will have the same horizontal coordinate, x equals to 1 here, right? So this is a straight line. This is the x equals to 1. And then now we can also see the same thing. This is the red vertex. This is the green one. It's just as if like the triangle B is looking into a mirror when you play this way, and then it can see its image as the C triangle. Next here, there's a rotation that will map the triangle C back onto triangle A. Oh, so when we need to do a rotation, we need a center of the rotation. So what does it mean? It means like, for example, you can imagine like you have like a rock. Okay, let me just try to draw like any kind of a rock, and that kind of rock is tied to a string like this. This is a string at a center O. Okay, and then you will swing the rock around. So I swing it, so it means that I will try to rotate it. Oops, not let to zoom it down, my bad. I just want to rotate it. So we will rotate it, okay? But when we rotate it, we want to make sure that it will be the same. My bad. Let me do it again. We want to do it at the same center, right? Like this. This is what I'm rotating it, right? You can imagine it, right? So let me do it again here and then rotate a little bit. Because the string doesn't go anywhere, it just still stick to the center. So I need to make sure that it stick to the center here like this. And then just rotate again, but it should stick to the center like this, right? You see what I mean? So it means that if you got a point here, a point P here, so when you rotate it, it should change the position. But that's also the same point P. Does it make sense? And what's special about this one is that you can see that through the center here. For example, if I have the whole rock tied to the string this way, but it's opposite to this one, like this, through the center O. So then you can see that the whole length from here to here And from here to here, they should be equal to each other, right? Because that's the same radius. That's the same length of the string that keep the rock rotating and swinging around. That's the rotation. That's what it means. So let's have a look at this one. You want to map the triangle C back to triangle A. And is there any special thing about this one? It's just the same thing, right? We can compare these two points here. So I think that maybe there's some special point to have a look at these red point here. You see that? Because it's actually the same point of the triangle, right? Like the equilibrium point. So I will try to connect them this way. Oh, now you see something special about it. If you have a look at the length of this one, you will see that this point is actually the point that divided the length into half, right? So should it be the center? Yes, it is. So this point happen to be the center because everything is symmetrical through the center point O. So what is this coordinate? That is have the x as 1 and have the y as 2. So that's the center of the rotation, because actually you just rotate this one back to this position for 180 degrees. So they symmetrical through this point O. Make sense? Okay, so let me know if you don't understand any part of this, and thank you. This is such a very good question.